Afternoon, everybody. How are we doing today? Welcome to Intro to Python, the fourth part of this seminar and the final scheduled version of the seminar. Um, so today we're going to be talking about collections. By the way, can everybody hear me okay? Excellent. I hear a little bit of feedback. Uh, okay, I think we're good. So let me pull this down. So, if you're just joining us for the first time, there is some preparatory things you probably need to go and do. Uh-oh, I think we have some unmuted people. What happened there? Thought I'd muted everyone. Oh well. Oh, by the way, we have Rochelle with us today. She's my co-host. She's with Nova Systemic, which is sponsoring and marketing these these seminars, and really appreciate all the support that they've given us and all the awesome things they do. So I'm in the IET division, so Information Engineering Technology. And Systemic is sort of our outreach program. And they do all kinds of really fun and interesting things. If you want to learn more about that, just go to the Nova website, or you can just Google Systemic. Put that in the chat. So, Systemic. They do. There's a fabrication lab out in the Manassas campus. All kinds of cool stuff. Other seminars, of course, that were advertised in addition to this. So I just want to give them a plug, especially this being the last scheduled one. I have, if you noted in the email in the PS, I have gotten requests to extend this into the summer, and I'm very willing to do that. I'm happy to do that, actually. The problem right now is just a scheduling issue. So I'll be sending out an email about that, and maybe probably a survey with some free times that I have during the week, because my schedule will change as I take on some summer classes to teach for Nova. And also, noted a few people who said that school, I know that might not be much of an issue over the summer, but that school didn't end until like 2:30 or almost 3, so might want to push them back a little bit. So I'll cover that in the email I'll send out later. So with that out of the way, um, we'll go ahead and get started. So just a review, if you haven't, like I said, set up something, you need to go to Replit to set up an account, or just log in with your Google account. Facebook, I believe, is also OpenID works, or GitHub. If you know what that is, you probably already have an account anyway. Then you want to create a new REPL, right? New REPL, and create, choose Python. And all this is available, by the way, and previous videos if you want to catch up on my website. Let's see. Pull that over. So put right here, more info. And there'll be a link to it, by the way. When you leave this meeting, it will automatically redirect you to this page, or it should, or ask you to anyway. So all the instructions are slides and videos of the prior sessions, and I'll be posting this session as soon as it's done. So that's all there available for you to catch up or go back and look at something that you might have missed, or to, whatever you need to do. All freely available, no password protection or anything. All right, so this, and so the review is that, you should be familiar at this point with basic input output, using the print statement to output input function to get input from the keyboard, saving things to variables. Again, Python is a duck typed language, dynamically typed, which means that it infers the data type based on what you give it. You don't have to explicitly say this is an integer, or a Boolean, or a string, or a float. It will figure that out for you. And I noted before how that can impact performance, but it makes the language a lot easier, especially for beginners. And one reason it's widely used for lots of different things, including machine learning. and scientific computation and lots of other things. And we can explore those, right? That's going to be part of that survey I send out. So branching, making decisions. So programs aren't particularly helpful if they can't do things differently based on different input or different states or the changing of conditions. So in Python, we use if, elif, and else. If you're familiar with any other language, this is going to look weird. It looks like elf if you just glance at it. It's else if. It's short for else if. So if a condition is true, then do whatever. Here I have the example dragon is friendly. If that's true, it prints this statement out. If that's not true, it goes and evaluates the next thing, which is an elif. And you can have any number of elifs. So you can have 20 if you wanted, right? Elif, elif, this, elif, that, elif. And the first thing that is true gets executed, right? And then it jumps out of this entire thing once if it finds something. If none of them are true, say if in this case dragon is friendly is false and dragon is asleep is also false, it will run whatever is in the else. So otherwise do this, else do this. That's what that is. And here's the nice little mini flow chart that demonstrates, shows this code. All right, so branching, then looping, that's what we did last week. So repeating code. And I talked about the fact that underneath the hood, right, all looping is a jump statement, which means jump to another line of code. So when you get to the bottom of the loop, it jumps back and then it asks a question, just like an if statement. It's essentially an if statement with a jump. And if this is still true, the condition, it will run the code again. Gets the bottom, gets the top, checks the condition. If it's true, run it again. If it's not, it ends the loop. For this particular example, this is a while loop. And that's very, very similar to the if statement, right? Because you have while, which is, you can think of this as like an if this condition is true, then do these things. And here I have to manage the counter. I'm counting here. A lot of while loops don't necessarily have a count. They have a value that changes from true to false or false to true that will start or end. And we'll see that in the game that we're going to do today. We'll do pieces of it. I've already pre-coded a lot of it because it's a long-ish game, especially for an hour. But we're going to do the classic word guessing game, Hangman. And so that will definitely be implemented. We'll need a loop because we're going to need to go and ask the user for a letter and then another letter and then another letter. And we need to make decisions using our branching here as to whether that was a correct a letter that was part of the secret word or whether it wasn't and what to do based on that, right? So we're putting this all together. And then the for loop, I mentioned at the end last time, it's just a variation on a loop. Loops are all really, like I said, underneath the hood, they're all the same. What the for loop does for you is it has automated features built in. So it saves you some time, especially in the case where you need to count, right? So here we had the how many ducks until goose. This is the duck duck goose game we did during the last session. So this for loop will automatically make the variable for you count, set it equal to 0. So we don't have to do that. So I'm showing you a parallel, right, between the for loop and the while loop. So here's the while version of it. This does the exact same thing, but it's the for loop version of it. And you can see we can get rid of this initialization, our counter. We don't have to do this. We don't have to declare the counter and set it equal to 0. We just need to say for count in, and then this special function called range. If you've used other languages, this is going to look also kind of weird because Python does it differently. But essentially what this does is it will get the range of numbers. Since ducks is going to be an integer, we converted the input to an integer here, so a number. It will get this, so if we say we put 5 in our input, ducks will be 5, and the range of 5, which again, the variable gets replaced by the value that's in it. 5 would be, the range of 5 would be 0 to 4. So if I put in 5, it would go 0, 1, 2, 3, 4. That's the range of 5, excuse me, is 0 to 4. and it will each time it goes through the loop, it automatically adds one. So we also don't have to do that anymore. We don't have to say count equals itself plus one like we did with the while loop. So you can see the advantage of using this construct, and that's all it is, right? It's a construct. It doesn't really do anything differently. It just does some things for you, so you don't have to write as much code, and it's easier to read. Um, so we can get rid of this line and get rid of this line, and we end up with just these two. And I'm going to show you this really quickly here. So we had this old while loop, right? This is duck, duck, goose condensed. How many ducks until a goose, right? So I'll run it over here. How many ducks until a goose? I'll put five. Oh, excuse me. Can't even type the right number today. Type five, hit enter, and it gives me duck, 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 which is one, two, three, four, five. That's right, right? So it went here and it went zero, one, two, three, four, five, because I did five this time instead of three. And of course, just note that if we mess up with the while loop here and leave off, say, the increment, which is adding one to a value every time we go, a decrement is the opposite when we would subtract one. So increment and decrement, you'll hear that a lot if you do programming. Run it, we'll end up with an infinite loop. Even, we can put one in and it will still run duck forever. So we're stuck with ducks and we run around this circle infinitely because our legs won't get tired because we're a computer. So stop that and put it back. Now let's look at the for loop, right? So this is exactly the same thing, except now I can get rid of this. I left these lines of code in, so it's equivalent. So you can see moving between these two that they are essentially the same, except I can get rid of the count. Except for putting it here. I just have to say what the name of the variable is in the loop construct at the top. So for count in range ducks, which will be whatever we put in, which again is, so the range is going to give us 0 to n minus 1, right? So n being whatever the number is here. So in this case, it would be ducks. So 0 to ducks minus 1. So again, if we put in 5, it's going to go 0, 1, 2, 3, 4, because ducks minus 1 is 4. So the computers start counting at 0. You'll get used to this if you do it a lot. They don't count from 1. It's a waste of numbers, right? Not to use the 0. That's all off switches in binary, right? So all zeros is the first number. So then it just prints duck. And also I went ahead and added another value to the output, which is count, to show what the count is. It automatically, right? So we don't have to do this. It's doing it for us. It sets it to 0, and then it counts up to 4. And we can see that through what I'm about to show you. In fact, I'll separate it even more. I'll put a colon between them. So you can see the duck and then the count beside it. So let's run it. And then I'm going to put in, say, 5 again, or I'll put 6, do something different. Let's see. So here we go. So we have duck, 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 right? And it's 0, 1, 2, 3, 4, 5, because I'm putting 6. So ducks minus 1 is 6, right? So the range is 0 to 5, which is 6 values, right? What we're doing with the range is just saying how many values do we want, right? How many times in this case do we want this loop to run? And the computer is going to start counting, or Python and most systems, pretty much all programming languages, will start with 0, not 1. So if we were starting with 1, we'd have to go to 6. But since we started 0, we end up at 5, and that is 6 values. So we get basically the same thing, right? So, but it's simpler, right? And we don't have as many places for mistakes. It's also easier to read, right? Because this is not necessarily the easiest thing in the world to read. It's simple now, but larger programs might be more difficult, and it makes more sense maybe to use a for in some cases and a while in others. Generally, you want to use a while for a simple condition check, right? If you're going to check a condition, is it true or false? That's a really great time to, context or use case for the while loop construct. Whereas if you're counting or you're going over elections, which is today's topic, then for makes a lot of sense. And I note this in the slide. So repetition for ranges or collections. And then I'll sort of break this down. What's really happening? Here's the nice little flow chart of it. It's basically like just like the while loop was a sort of like an if statement checking a condition. The for loop is similar, but it adds in the counter for you, right? You don't have to deal with the counter. So essentially, under the hood, it's still doing this condition. That's why I put it in gray because you don't type that. You don't put it in as the programmer. It's not over here. And you also don't do the count equals count plus one. So we look back, we get rid of this add one to count, plus one count. And I made this color sort of like the statement because it happens automatically because we have a for loop. But otherwise, just the same, right? Under the hood, it's just a jump statement with a condition check. It just they call it the industry term is syntactic sugar or syntax sugar. So in other words, it's a sweet way to write something that is easier, that is more palatable for both the programmer and anyone reading the code. But otherwise, it's just doing the same thing. All right, so hopefully everybody's sort of ish good with loops at this point. So let's move on. And today's topic is collections. So what are we collecting here? Are we collecting butterflies or bugs or numbers? Hopefully not too many bugs today. Of the error kind. Um, so there are different kinds of collections, and what collections are just items, lots of things of the same, generally of the same type, in one structure. So if you recall, or if you go back and watch the video on the Mad Libs game that we made, we had multiple, say, verbs, multiple nouns, and we basically used the construct of, hey, let's just name the variable that holds each one. Say if it were two nouns, we'd say noun one, noun two, verb one, verb two. But that gets a little complicated and, messy after a while. It's harder to manage, right? It's hard to automate going over, say I wanted to get a list of all the verbs, right? I would have to just put in the actual variable names, verb one, verb two. Whereas if I had a verbs list, which is a type of collection, which if you're familiar with other languages, the list is essentially equivalent to an array. Arrays are values of the same type in an order, indexed order. So the list is going to be your go-to if you're thinking about using an array. So here we have a list, and here's the visualization of it. So we have my list. I don't want to name it list because that's a special word. It's a keyword. We can't name something list in Python because that is a special term reserved for the language, just like we can't name something print or for or in, because the language looks at that and it says, oh, that's something special. It has meaning. It's not just an identifier. So as long as I had to put something like my list. Now here it has list, but it's capital. That would actually be okay, but I wanted to make sure in this particular code example that there's no ambiguous naming here that leads you to believe you could name something that is a reserved word. Okay, so we have my list, and it consists of 6 values. All of them are integers, and it's 0, 1, 2, 3, 4, 5. Very simple, right? And here you can see this is what is in memory. So we're trying to think abstractly here, and we're thinking, how is this stored in memory? Well, it's just one value after the other, stored in order together contiguously. So there's no break. There's no break here. They go, so whatever memory location the start is, the next memory slot will have the next item, and so on and so forth until it's complete. So, like I alluded to here about using for loops for collections, it's very, very handy because we can do something like this. We can say for, and this is our count, so to speak, in my list. So for item in my list, and this can be anything. This could be I, this could be X. It doesn't matter. It's just like the variable. Um, So what we need to do, or what it's happening here, is it's going through automatically every element in the list. So let me go over to to the code for collections. So let's go ahead and put one in here. So for in range, instead of having ducks here, we're going to take this out, and I'm going to copy over the code. By the way, I think somebody's unmuted themselves. Um, anyway, let's see. So yeah, I can hear some background typing noise there. Let's see. Yeah, we got it. Good. All right. Thanks. Um, Instead of ducks, we're going to say my list, right? So we put my list equals, and then the special notation here is square brackets. So it's really boring. It's the boring list, the type of collection. It's the most simple collection, sort of. There's another collection we'll talk about. It's string. The string is actually a collection. Um, and we'll see that in a moment. But it's boring. You can think of it that way. The list is the basic one, so it's the basic square, right? It's the basic bracket. It's not the curly and interesting bracket like this is a curly brace or bracket, right? That'd be the shift bracket. It's just the regular square old bracket, right? Okay, so let's put that in. Let's put our values in 0, 1, 2, 3, and they're separated by commas. Four, excuse me, 4, 5. So we got 6 values here, and let's say for x, we'll just call it x. So x will be set or assigned each value as it goes through the collection. So instead of range ducks, let's get rid of that and let's change it to in my list. So for x in my list, and then print out each one x. Okay, so let's do that and get rid of this, and then say we'll just say done instead of goose. We'll say done. So let's run that and see what happens. So what it should do is 0, 1, 2, 3, 4, 5, right? It should print those in order. And there you go, 0, 1, 2, 3, 4, 5. So that was pretty quick, right? That was a lot easier. If we did a while loop, we'd have to say x equals 0, and then while x is, or excuse me, yeah, x is less than the length of, and this is a function of my list. While that is true, we print x, and then we'd have to say x equals x plus 1, right? That's a lot. That's a lot more complicated. Right? I mean, it does the same thing. I'll run it. We'll do it twice now because we have both loops. Say 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. But you can see how advantageous the for loop is for collections because it automatically handles all that messiness for you. And you get this nice little 2-line program. Now let's make it a little more interesting. So it's not very interesting to just do 0, 1, 2, 3, 4, 5. Let's say do 1 or 5, 3, 1, 4, something like this, right? So it's not an order anymore because you may be thinking, maybe you're pulling a trick on me. This isn't really the values. These are just the indices, the index values. So this is where 0, this is the 0th index. Remember, everything starts with 0. So the first value being the 0 index, 1 index, 2, 3, and so on. But here, hopefully you can see that I'm not pulling a trick. It's just outputting the value at that index. So let's run it, and we get 5, 3, 1, 4, right? So it's not giving us the index value. Now, if you wanted the index value, so you wanted to know that this was the 0th index, this was the first index, and you can see that here, by the way, list 0, list 1, you use the same boring basic list square bracket notation in order to get a single element. Right, so I can know, for instance, I just want to print out, I'm going to take this, comment these lines out for the moment. And I'm going to say, my list, what is at my, I'm going to print out, right, do print function here. And then my list, print out what is at index 2. So anybody know what's going to print out? What is an index 2? Put it in the chat. So I got 1, 1, very good. It is 1. So some people, when they first look at this, and no shame if this is what you thought, because programming, we're not born knowing this, right? This is very foreign to normal human common sense or thinking. So we start with 0. This is this would be my list 0, this would be my list 1, and my list 2 is this position, right? So it's the third element, but the index of the third element is always 1 minus the element number, right? So if it's the third element, it's 3 minus 1, which is 2. Okay, so let's run it and prove it. Oh, yep, it's 1. Very good. So 3 would be the fourth element, which would be 4. So run that, and we see it is. So hopefully you get an idea now of lists. It's pretty straightforward, right? And we can also do strings. We don't have to do numbers, so we could say 1, right? 2, and then 1, 4. Let's see if that works. So, because a lot of languages don't allow you to do this with arrays. So let's see if Python does or does not allow this mixing of data types. Let's try it. It does. So Python is, again, it's a lot easier to learn than say Java or C or C++. A lot of that is due to the fact it one and done, yeah. Um, a lot of that is due to the fact that you don't have to worry about types as much. Again, that's a performance issue. You do have a slower program, so if you're starting to write high performance code, you're going to have issues. But you can mix and match different types within a list, which is one reason it's not called an array, right? Because technically an array has to have all of the same data type. So if we wanted to store integers, we'd have to store all integers or all strings or all floating point decimal numbers. We can mix and match like this. With a Python list, we can. So it's not quite as boring as the brackets would seem to indicate, but it's still the most basic, right? Okay, so I sort of gave you a hint earlier that we were gonna see that something like a string is actually a collection. Is actually a collection. So let's say my string equals some text. All right. So this does not look like a collection. To most people's eyes, this is not a collection, right? It's a string. The thing is, and I think I mentioned this at least once or twice in previous seminars, a string is merely an array or a list of individual characters. So this is actually a list of capital S, excuse me, lowercase o, m, e, space, lowercase t, e, x, t. So if I'm telling the truth, that is, I should be able to iterate or loop over the string just like a list. Excuse me, not that, my string, right? My string. So for x, so x should, if this works, if I'm not lying, right? If I'm not leading you on, x should become, as the loop iterates over this, what I'm claiming to be a collection, it should print out each letter one at a time, each character. Let's try it. So I go run, and lo and behold, there we go. It prints the first one, second one, OME, space, TEXT, done. Neat, right? So maybe you're thinking now, hey, that's kind of neat. I could actually get pieces of the string and then work with it too, because we showed earlier how to get a particular value out of a list, right? By using its index. So we could say my string and say I wanted to get I want to know what character is at the fourth position. Okay, well, the fourth position is actually number 3. So let's say, excuse me, index 4, which would be position 5. So that should be 0, 1, 2, 3, 4. So it should be a space, right? So let's print it out and see if that's correct. Yep, empty space. And then we put 5, we should get a lowercase t. Ooh, that's neat, right? Very, very cool, I think, anyway. Yeah. I guess if you're tuning into this, you probably at least have some affinity for this type of thing. Otherwise, you wouldn't be spending your Wednesday afternoon with me and Python. So now that we sort of have this, we can also do things like string slicing. So for instance, I can do string colon 5, my string colon 5. Let's see what happens with that. Interesting. So it printed out a sum. What it did was it prints out everything up to 5. So pause after each letter. I mean, certainly you could do that. Uh, you would just have sleep function, but I, that's a kind of want to move on because we have like 23 minutes left, and if I'll preview this, this is our program, so it's a lot to go over. But yeah, you can definitely pause after every character using a time function and sleep. By the way, if you're looking into that, so sleep. Um, so if we do the colon behind the five, let's see what happens to that. We get everything after. Right? I took the comments off of this. I should put it back so you don't see that for loop. So we get everything after it. We could also do a substring within, say, between two values. So we could say index one, which would be the O, to index six, which should be, let's see what it is. It's the T, right? So we end up with 1 to 6. This is pretty handy, right? So you can do string, what's called string slicing. So slicing the string up. So very handy tool to look through, and you can maybe see where we're going with this, right? This is very useful for checking whether a letter exists in a particular string, whether or not, say, the user has picked a letter that exists in our guess word, our secret word that they have to guess. So we take that and go and use it. Now, I want to go over just a couple more before we go into the program. And so here's the string as a collection. So in this case, I made Python the my string. And here you go. Here's what it looks like in memory. So Python, and here are the indices of them. Now you'll notice it also has negative indices. This is if you want to work with the string or in reverse. Say I didn't care about, I don't want to know what the first or the second or third value is. I want to know what the second value from the end is. Well, Python makes that super easy because all you have to do is use negative values. -1 is the first. Now it's not. It doesn't start at 0 because 0 doesn't have another. You can't differentiate -0 and 0. That's There actually is such a thing as -0 and 0 in some numeric systems and computers, but that's way beyond this class. So we can't start with 0 here, right? Because then it would not know that we meant for it to be -0. So we need to start at -1 and -2, -3, and so on. And so I'll just show you just really quickly before I move on to something else that this works. So let's do -6 here and see what happens. We get E. So -1, 2, 3, 4, 5, 6. So we get the E. So that's pretty cool, right? So we can go either direction we want to go just by changing the sign, which again, this is not something you can do easily at all in a lot of other languages. So you can see how Python is sort of the language of choice for working with lots of data because you can throw a lot of data is strings, right? That is a lot of data you have to work with. Of course, numbers as well, but it's very simple and easy and straightforward to manipulate the data and get useful results out quickly. Let's see. So now the last one I want to cover is a dictionary. So a dictionary is another type of collection. And the collection, in this case, allows us to look things up, not just by index. So in our list, our string right here, which is a kind of list, we're looking it up by index, right? We can put the index in and get what we want out. Here, we can actually name our indices, which is very helpful, right? And it's called a dictionary because you look things up in it, just like with English or German or French or whatever dictionary. You go and you find the word you want. It gives you the result. It gives you what it's defined as. It gives you the value. Now, in this case, a dictionary is made up of keys and values. The keys are the key to looking them up, right? That's why it's called a key, is because you look up the value. It is uh, it's the key to getting value, right? I could go on with other kinds of metaphors, but hopefully that's fairly straightforward. This is a nice graphic of that. So in this particular one, I left off the G because I ran out of room. But here you have the characters, AOG. And they map to the values alpha, omega, and gamma. So I'm going to go over here to the code, the same code that we have there, and I repeated it here. Let me put this in comments real fast because I want to show you that as well. So what I'm doing here is I'm making a dictionary. Now this one is more fancy, right? It's fancier than the simple list because it has keys and values. It doesn't just have a list of values. Um, so it gets the fancy braces, which are curly braces or curly brackets. People call them different things. But essentially it's the boring bracket with a shift, right? So you shift regular bracket, you get the curly braces. And what you do to define this is you put the key, colon, the value, and then a comma for your next item. So key, colon, value. And then the last one we'll go ahead and put in now, which was G, right? So we'll say G colon again. And then it ends just like the list started and ended with the same character, right? We have the same uh, delimiter character, which is a fancy word for how we terminate or divide things up. The curly brace. So now we have this cool dictionary, which is, I guess, not very cool because it only defines three things that we can look up. So we can loop through it just like with a list. So for item in my dictionary, print item. So let's do that. And let's see what we get. I'm going to comment the rest of it out. So do that, and we go AOG. Well, that's interesting and maybe somewhat helpful because this would be as if we are thinking of a regular dictionary. This just gives us the list of words. This doesn't give us the definition, or in this case, the value, right? We actually want to look up, say, what the value is. So just like we had indices with, excuse me, we had indices for lists, we also have a way to get to or index or look up the values in the dictionary. So I'm going to print out and I'll show you the notation for it. So my dictionary, say I wanted, again, the reason it is fancy, but in this case we're doing a simple lookup. So you use the regular boring brackets. We put in the value that we want to search. So let's say O. Print out or give me the value of the key O. So let's see what happens. Let's run this. And it prints out omega, which is very handy because I don't know about you, but a lot of times when I'm keeping a list of things, I don't keep the list as, let's say, I don't know what's at index 5. Like in my grocery list, I would say I wanted a particular brand of bread or milk. Well, I might be able to find it by looking through the whole list of items if it's a list. But I'm not going to know that the brand of milk I need is any certain thing unless I know milk is like item 2 or 3 or index 4 or 5, right? That's not very handy. That's not very useful. It gets kind of complicated, and we want to use the computer to do stuff for us and make our lives easier and not make our lives harder. So to do that, we'd say, hey, I want I don't know what brands there are. So I'll do orange. So OJ for orange juice, then milk and bread. So I don't know. Farmers Delights. I'm just making these up. These aren't real things. I don't think anyway. Um, I think Borden actually is a milk brand. I can't remember. And then OJ, let's say squeezed fresh brand, right? We're just making up things. So now I have something I can remember OJ and milk and bread. I'm not going to remember these things. So I can just go look it up, like I could at a dictionary, a regular word dictionary, right? So I look up OJ and it should give me my brand for the value. There you go, squeezed fresh. If I want to know what milk, or say bread, let's do bread. Boom, it gives me what I want. But again, the loop, not very helpful in that it gives only the key, not the value. There's another way to loop through that gives us both, and that's what we're going to see here. So Oh, the Replit. There we go. Replit kind of fixed itself. Good. Okay, so we can do this thing called it's destructuring. That's the technical term for it. It's when it pulls out multiple values and inserts them into multiple variable containers. So here we have key comma value. We could also do k comma v or x comma y. Again, the name doesn't particularly matter. I'm just naming them this because that tracks right with the definition. So this is a key, this is a value, it's key value, key value. We need to actually get this special use the special method of the dictionary type, which is items. So this returns the item. So it'll return each item. So this is an item, this is an item, this is an item. And it will destructure or put in the value and the keys to in order. So key value. If I put value key here, the value would actually have the key and the key would have the value, right? So you can confuse yourself if you don't put it in the right order. But here we get both. So we can see what's all in the entire dictionary, one at a time. So let's run that and see what happens. And lo and behold, we get OJ colon, because I put a colon here, right? Squeeze fresh, milk board, and bread farmer's delight. So that's pretty useful. Now I think we have enough basically to start talking about the game. So what is Hangman, first of all? It is basically a game of guessing a word, right? It's a macabre, as I put, very sort of a dark word guessing game where your character is over time for every wrong answer you put in, it draws a little more of the character. And here I have a little hangman character, right? And I've made it using a list. So each item in the list, right? Lists regular square brackets is a new row of the character, and I made this up. It looks kind of dumb, I know. And if you'll recall, this is a bit of a review. Anybody remember what this is? Why? What's this actually going to print out? These two backslashes. Anybody remember? It's a special color too. It's highlighted. It's sort of pink, and that there's a reason for that. He doesn't actually have sort of a mutated left leg. There's a reason here. Exactly. So this is see, just like I talked about the fact that a variable name can't be named for or in or any other thing that's reserved or keyword of the language. A backslash is an escape character. So if you recall, we could do something like backslash n for a new line. So that would make it sort of like doing a return, hitting the enter key on the terminal. But if we want a backslash, well, backslash by itself is a special character. So to get an actual backslash, we have to do backslash backslash, and that tells Python, "Hey, I actually want a backslash, not just some special character." Right? So that's why that's there. This will end up printing out just one backslash. So I've used a list here, and this would be list index 0, 1, 2, 3, 4, 5, 6, 7. So in other words, I've built myself, I'm going to go back to for loop and get rid of this and start off here. I'm going to put this by itself. And now what we're going to do is we're going to build our little guy one step at a time. Right? So I could say print hangman, and then I need my square brackets, right, for my index 0. So if I print index 0, I get just the thing from which he hangs, right, the board or whatever, the gallows technically, right. And then if I wanted to print the next one, I do hangman 1, index 1, which is the rope, right? And then so on and so forth. And if I wanted to print the whole thing, I just do a for loop for uh, part. I'll just call it part, right? Because remember, it doesn't matter necessarily what you call this. Um, oh, thanks, Rochelle. Um, it doesn't really matter what you. Oh man, I think we just lost everyone. Crap, 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 crap. Um, Hey, can everybody hear me? Or one person who's joined back? I made her the host, and yeah, when she got off, it closed the meeting. Oops. Um, Looks like some people are coming back on. Everyone hear me? Abena, Julian, Sonia, you guys able to hear me? Okay. Sorry about that. I guess Rochelle didn't. She didn't realize that I had, since I made her host. If she closed the meeting, it actually prompted her, but it just it shut down the whole meeting. Oh well. Oops. So thanks for joining back. Apologies about that. For anybody who doesn't join back, hopefully they'll at least see the rest of the recording, which I'll post. All right, I think that's most of the people who were here, so I'll go ahead and sort of continue. Let's see. Oh, my screen's not shared, right? Probably not. Let's see. Share the screen again. And there we go. All right, everybody able to see the screen again? Just make sure we're okay. Excellent. Sorry about that. All right, so pull this back over and get rid of this. And let's see, where were we? Right. So it doesn't really matter. I was getting back to the for loop here. It doesn't really matter what we call this as long as we don't use a keyword. So we say for part in and our list name, which is Hangman. So we say Hangman, colon. Now we can print out each part without even using the indices, right? So we can say print Hangman, and then, or excuse me, not even Hangman. You just print the part. It actually grabs out the value. It doesn't give you the index. It just sets part to each string in this list. So we print part for each. So run, and you get, there he is, our nice little Hangman. He's sort of not happy, not sad. He's just neutral about it because he's cool. He's got a huge head too, relative to body. So he's not really hurting, even hanging here. He's just not having a good day. He really wants to go out and run around in the sunlight, which I'm sure a lot of us do as well right now. Okay, so let's go back, and I'm going to try to wrap up. I know we have like 5, 6 minutes left. A lot of this code I had to sort of write beforehand, and I'll try to explain it instead of writing from scratch. We certainly don't have time to write it from scratch. I'll also give you a link to after this afternoon at some point. I'll give you a link to the graphical version, which I made that actually draws a nice graphical little. Well, it's not that nice. It's kind of a dumb looking hangman, but it's better than ASCII text, just a text character. All right, so in our program, we know how to draw the hangman now, and essentially for every incorrect guess, as we loop around asking for a guess every time, which is what this is, we're going to draw one more line of the hangman character. Okay, until we get to the bottom, and then you lose, right? And we need to set a guess word and set this flag. It's called technically a flag, called game over. We can call it done, or you know, exit game, or whatever. Game over, it makes logical sense to me personally, but it might not to you. And it's a Boolean value, right? Remember, we don't have to say it's a Boolean. If it's true or false, it is Boolean. So we say game over is false because the game starts not being over, right? That would be kind of pointless. It's not true. And then we set our word, and we'll have our guess word to be password. Okay, and then we need a character list. We don't necessarily need this. We could actually work directly with the string, but I want to make it a list, of an explicit list. So this for loop right here just takes each one of the characters, right? For I in range, right? Length of word -1. So it gets the length of this string and it subtracts 1, and then it loops through and it appends or adds onto this list called character list. It adds on each character one at a time. And then we have a character list that we can work with. Then I have a dictionary for the guesses. I have 2 items in my dictionary. I'm keeping track of all So I named this key all, and I have an empty list. By the way, you can combine collections. So this is a dictionary where each item has a key of a string and a value that's a list. And what I'm doing here is I'm going to say every time I have a guess, I'm going to add that guess to the all item list. And if the guess is correct, I'm going to add it to the correct item list. So this will make a little more sense, hopefully, when you see it. And in terms of incorrect guesses, I'm not really keeping track of them except for the number of them. So I just have an integer here. There's different ways of implementing this, by the way. I mean, there's you could think of all different ways you could organize it. I was just trying to make sure that we covered lists, dictionaries, and loops, uh, and then strings as well. So I'm going to set the initial. I'm going to initialize incorrect guesses to 0 because you start out with having no zeros. And then I have this function here that clears the screen. All that does is call the operating system clear. So it's just going to reset the terminal, right? Because we want to redraw it every time. At least I do. Every time we draw the character, right? And then I call a function I've made. By the way, this is a little bit of an intro to functions. Draw Hangman. So this function takes two arguments. Remember, we're arguing at the function. Remember, we talked about that before. But this is a custom function now. This is one I wrote, not one that's built into the language. We are passing in this list, Hangman, and we're passing in the integer incorrect guesses. And now the reason for this is because this function that I've made needs access to the entire drawing, which is composed of these items in a list, and it needs to know how many incorrect guesses there are, because that is going to determine how many items of the list it's going to end up drawing. Right? If we get one incorrect guess, it's only going to draw the first index, 0. If it's 4, 1, 2, so 1, 2, 3, 4, it would draw down to here. Right? So that's why I have it. And I'll go up and show you just really quickly the definition draw hangman. It's actually pretty simple, right? So draw hangman, and all it is a loop that prints out each character, or each, excuse me, not each character, each line, each item in this list, up to incorrect guesses. So you should know this, right? We talked about something in a range. So if we pass in the incorrect guesses, if we got 4 incorrect guesses, range 4 will print indices 0, 1, 2, 3, which is what we want, because 0, 1, 2, 3, that prints out all of that to here for 4 incorrect guesses. So that gets us our little output, visual output for the user to see the hangman being drawn one line at a time as this number goes up for incorrect guesses. And then I have print word, and I have another function here. I don't want to show the word, right? That defeats the point of the game. The game is for you to guess what the word is, and you see blanks for each character that you have not guessed, right? Which you start off with all blanks. So I have another function, get partial word. That's just what I named it. You could have named it something else. You could have said, print out current state of word, or current word state, or blanks, or whatever. And I pass in as the arguments the word itself, which is our guess word, which in this case is just password, and then guesses. But I don't pass in the whole dictionary guesses. I pass in the value of that's at the key correct in guesses, which you'll recall, correct is simply a list. This is an empty list. I start off with an empty list, right? So you can declare an empty list, just like I did here, here, and here. So if I'm passing this, I'm actually passing to the function a list, not a dictionary. I'm just using the dictionary to get the list, right? Because it's inside the dictionary. Hopefully that tracks, sort of. If it doesn't, you can go back and watch it, and I'll give you this code, by the way. I'll make a link to it. It'll be on the website. So get partial word, we'll go back and go up and look at its definition. Def is how you define a function. Def is short for definition. Get partial word. So here's our variables that we're passing in these things. We have word and correct guesses, which is the list of correct guesses, characters. And we start off with output, which we're going to end up returning a string, sending back a string that we're going to print out. You'll notice it's different from down here in Draw Hangman, where I directly printed. So this is actually sending back the string and not printing it out directly. But more importantly, we start off with a for loop, just like we need to because we're going to be looping over a collection, right? We start off with if, and then we ask a branching question within each time. So we're going to go through word, which is this length of word -1, because remember it has to be the length. You'll see why. If you change this around and take off that, you'll see it won't work correctly. Um, this gets tricky. Off by one errors are very common errors in beginner programming. So I'm asking here, is word the current character in, and this is another neat thing about Python, all I have to do is put the keyword in to know whether or not the list of correct guesses contains the current character. So it loops through the entire word, looking at each character, and it asks, is that in the correct guesses? In other words, has that been put in as a correct guess? If it is, then the output is actually the character itself. We reveal the character, in other words, if they've guessed it. Okay? And otherwise, that means they didn't guess it, right? It's correct guesses. We output an underscore, which is to say a blank, right? We have a blank. So to start off with, and this is the join function, it just joins using this as a delimiter or separator. You could use commas, but spaces make more sense in this case because it's just a word. So in the very beginning, this will print out a blank for each character and then a space between them. So it'll be nice and separated because a bunch of these together, you're not going to tell how many characters there are visually very easily. So I made it use a space. So I'm just gonna run it real fast, and what's gonna happen is you're gonna see it also prints out your guesses, which is just the list in the key, the value list from the key all in the guesses dictionary, right? So let's go ahead and run it just to see what this is so far, and see it prints out space delimited or space separated underscores because I haven't guessed anything yet. There's no guesses, it's empty. And I guess a letter. Now, at this stage, guessing a letter is just an input function, right? And I'll separate this so you can read it a little more easily. Guess equals, instead of integer, I don't want an integer anymore. I need a string, right? Because, well, it's a letter. So input, guess a letter. So that'll print out guess a letter just like it did, and it'll have to take the input and convert it to a string. And then I want to convert it to lowercase. That's what this does, the dot lower. There's a reason for that. It's because matching characters. Yeah, you could use a car. You could definitely use car. I'm just trying to simplify it and overdo it with the data types. I would, but definitely you'd use car. So here we end up getting the reason for the lower again, really quickly, is that this and this are not the same to the computer. If you said is it an A, well, a capital A and a lowercase a are not the same. They're actually different characters in the character table and they have different values. So what I'm doing here is I'm sort of normalizing it or converting it. So I'm forcing whatever the user puts in, capital or lowercase, to be internally a lowercase. So I know I can peg it against a lower, or can compare it against a lowercase value. And I know I've put my word in so it's all lowercase. Now, if I put uppercase in, then it wouldn't work, right? But that sort of covers that. Okay, so then we have our little if here, which says if guess in guesses all, which means the thing that I just put in, is it inside the list, inside the dictionary guesses, the list all, is it already there? If it is, we already guessed it. So I print, you already guessed that. And then input, enter to continue. This will pause, by the way. This is a really cheap kind of way to pause. Is just to get input and then not do anything with it. No equals, right? It's just input. And then I say continue. Now this is a new one. Continue basically says don't do anything else in this loop. Go right back to the top and start over as if none of this happened, right? So continue means instead of going to this line and continuing on here, it continues the loop, which means it jumps to the bottom and then jumps to the top to while. Because I don't want it to do any of this stuff here. I don't want it to add another guess if we've already guessed it, right? I want it to just skip to the next guess, which is what I do. So that's a shortcut, all right? And then if it gets to this point, that means this was not true. I will add to the all list inside of the guesses dictionary the guess. So now we're going to store what they guess, no matter what. And then I ask the really important question whether or not the guess is in the word. And in this case, the word is just a string. But because a string is a list, is essentially it's a collection. I can use the in keyword because it will look for whether or not this individual character is inside of this string word, which is our guess word. If it is, this is true. If that is true, then we do what we need for handling the true, right? Which is we add the guess to the correct list, and then we print out, hey, good guess, which actually will just end up going away because I took away the pause. So I need to comment that out because that might be confusing. And then I ask the question, is word complete? Which is a function that I created. And I pass in the word itself and the correct guesses because I want to know at this point, did they just guess the last letter that they needed to guess? If they do, I need to end the game and tell them they won, right? Which is what happens. And I'll skip that because we're already way over and I apologize. So the else is, it's not in the word. So that's an incorrect guess in the else. In that case, we say incorrect guesses equals, and this is a number, I need the length of how many are in the all guesses minus the length of correct, right? Because it's either incorrect or correct. There's only two states that we've made up. So if I get the number of all guesses and I might have subtract the length of the number of correct guesses, I get the number of incorrect guesses. There's actually other ways to do this. I'm just trying to use as much functionality in terms of like getting the length of a list or collection and showing you how you do these calculations. This is an academic sort of program, right? I'm trying to help you to learn various features of the language. And then I ask if hangman length, which is the number of lines for our little character, is equal to incorrect guesses, that means we lost. Because if we've guessed incorrectly as many times as there are items to print out, that means our hangman is completely drawn, right? And that means the game is over. So that's what this does. And then it sets win, which is I have a flag for winning, and it says win equals false. And then we also set game over to true. So whether they win or they lose, game over has to be set to true. Because remember, our loop continues as long as game over is false, equal to, equal, false. So if we set it to true, is when it gets to the top, it's going to end the loop. Right? That's the whole idea. And then we're not in the loop anymore here. If win, which is just going to be true or false. So if win true, great work, you win. Else, clear and draw the hangman one more time because you need to draw the whole hangman. You'll see why if you run it. It doesn't draw because it'll only draw down and leave off the legs basically. And then it says you lose. Your character's having a bad day. So let's go ahead and finish out running it, and this will be sort of the end of it, and I'll take questions, etc. So we know our word, right? It's password. PASSWO, or is it? Let's see. Or it should be PASS. Did I misspell it? Well, let's just go ahead and try it. Guess a letter. So I'll do S. Oh, there's two S's. There's definitely something awry here. I think I was messing around with it. I may have see the off by one error. See how easy it is to happen. There's an off by one error here. I can already tell. That's what I was trying to think to myself as to where it happened. Because I've been moving this code around to show pieces of it. Anyway, so we'll guess something incorrectly. Let's say password does not have F in it. So I guess F. Oh, we drew the first line, right? See, it drew the first line, which is happening. Word, no, not word. It's a draw hangman, right? So there's one incorrect guess. Okay, so guess another letter. Let's do Z. Oh, nope, that's not going to work. X. Nope, that's not going to work. And see, it's printing out my guesses too. I'm using the join function again here, which joins every element into of this list of the dictionary guesses, the list that's in all. It joins it with a comma space, so it just puts them together. Pretty handy, right? Um, so let's continue with bad guesses. I'm gonna do the same one. I'm gonna do X again. Say I forgot that I did X. I can't read. So I'm just gonna put X in. And it says, oh, you already guessed that. Because it knows when I ran here, if guess in guess is all, which this is all the guesses, and X is in that, you've already guessed it. And then you'll notice it just skips back all the way to the beginning when I press enter. It starts over as if nothing happened, right? That's the continue part. Um, Now let's do P for a correct one. And then there it puts that, but I don't know why it did not actually increment. Something happened there. I think that might be part of the off by one error. So A, oh no, it's not. Excuse me. It shouldn't draw anything else, right? Because I'm guessing correctly. Let's do Y. That's not in there. Oh, there's the face, right? Let's see. We'll do L. Still not there. There's neck. Uh, O is there, so we should get that. D is there, so we should get that. Yeah, that's the off by one, so it cut off the last letter. I'll fix that before I send the code out to you. It's just an off by one. Um, so let's do some other wacky ones like S. Oh, that's already there. We already guessed that, right? N, not there. Oop, we got the arms. We're getting close to not winning this. So then let's see, we did Z, we did P, let's do I. Oh, oh, we only got one more chance now. Oh no. So we did D. We only really have W or W and R left. So we'll do R. Oh, there it filled in R. And then let's just lose on purpose. So I need to put what I need to put. It's like B. Bravo. Oh, you lose. Your character is having a bad day. So that's essentially how you use loops and collections, which here we have a list and here we have a dictionary, and then lots of looping right over them because you loop over collections. That's pretty much how you most of the time that's what you're doing with collections, and we use that to make a fun little game, which is a classic Hangman word guessing game. Like I said, there is a graphical version. It's not complete yet. Also, I'm going to give you the version that actually uses 1,000 word little dictionary I made. I have 1,000 words here. The thousand most common, about 1,000 most common English words, and it pulls a word from it. It actually goes and says get random word, and this is an intro to how you read from files if you want that. So this will be included in what I will make available for you. And it reads from the words.txt, and it puts all each line as an item in a list, and then it basically picks one of the words using the randint 0 to the length -1. So it'll pick from 0 to whatever the last item is, and it'll randomly return a word, which is pretty cool because then you could play it yourself and you won't know what the word is, right? Unless you've memorized all 1,000, and even then it still wouldn't make any sense because a lot of them are the same number of letters, or very similar. So I'll do that. And then in addition to that, I have here Python. This is some of the basic code for drawing the Python, or excuse me, the Hangman character. So I'll just run that really quickly. Hopefully this is still the correct version. Yeah. So there's my little graphical Hangman. This is not complete yet. I didn't have time last night to complete it. But essentially, you could use this each piece of the drawing in some kind of collection structure to have a nicer graphical interface. Pygame, by the way, is one of the major suggestions from a few people in terms of extending this series. So this is using the Pygame framework, which is basically a game drawing, and you can do collisions and all kinds of cool stuff really easily, and run it in a window. Actually, this would be a window if you ran it on Windows. It's cross-platform, so works on Linux and Mac OS as well. So that being said, I'll fix the off by one error and share this code, and also, of course, the video, which I'll stop now.